previously on what is probability. So last time we talked about quiz scores, test scores, and homework scores, and how we take all of these scores to create one number that is representative of the entire population of scores. And what we do is we take all of the quiz scores and we average them together, add up all the numbers, divide by the number of numbers, get a quiz score average. Then we get a test score average. Then we get a homework score average by adding them up and dividing by the number of numbers. Then, based on the mood of your teacher, you get weighted. So some scores become more important than other scores. And this is basically just on the principles that your teacher has or their mood. They then create a weighted average where they multiply the weights by the averages of your quiz scores, test scores, and homework scores. So they take 35 weights and multiply it by the 68.7 average quiz score. And then they take 40 and multiply it by your average test scores, and they take 25 and multiply it by your average homework scores. Divide everything by 100 weights, and that is how you get an F on your report card. After you get this F on your report card, other things can happen. And so we've talked about what other things could happen. Firstly, we decided to talk about scales. And with scaling, we just add something to each score, and your F becomes a magical B. That is highly rare, but possible. We also talked about curves and how curves have very little to do with how well you did in the class and how much you know, and more about what other people know. And as long as you sabotage a whole bunch of other people, doesn't matter that you are not as smart as Alice, you still get an A. That's how a curve works. What is probability? Episode 5, Samples. Illustrated and narrated by Izzo. So today we're going to be talking about what is probability, particularly when we have a beautiful population and we are taking chunks out of that population to make a sample. When we make a sample, we have different probabilities of what will end up in the sample. The study of probability is all about what from the population will end up in the sample. We know everything about the population and we're guessing what's going to happen in the sample. However, probability has an alternative. What happens if we know everything in the sample and we want to guess about the population? That's called the study of statistics. And that's what we are going to be talking about today. We are going to be talking about how these samples get to be samples and how we get them from the population and if they're representative of the population. So we start with a beautiful population and we start with our normal deck of cards. Only one thing happened. I took this deck of cards and I threw out a whole bunch of cards. This is not my regular deck of 52 cards. Something happened to this deck. For some reason, there are only 20 cards in the deck. That's a problem. So what I'm going to do is I'm going to take a sample of cards. And what I do is I take a sample of cards and I pull out 4 cards in the deck. Okay. So I've pulled out these 4 cards. There are only 20 cards in the deck. I've pulled out 4 of them, and I see that they're all face cards. Well, this makes me think that the population is only face cards. It looks like I have all 4 suits, so I didn't get rid of all the hearts because I've got the Queen of Hearts. But I don't see any numbers. So I'm guessing I got rid of all of the 2s, the 3s, the 4s, all the way up to the 10s, because I don't see anything there but a face card. Now, is it possible that I just got lucky? Yeah, it's entirely possible. It's entirely possible that this sample isn't representative of the population. It's entirely possible that there is a 5 of diamonds in the deck. We don't know. That's the statistics. That's the study of statistics. It gets a little bit wonky. And that is what we mostly do in life. Most of the time, we don't know what the population is, and we are going based on just the samples. So here we've got a nice sample, and we've got some people are sick, some people are healthy, some dots are healthy, and some dots are sick. We've got 3 dots that are sick and 7 dots that are healthy. So I'm saying 30% of my population is sick, and 70% is healthy. That's great, but is it? did I get this sample? How did this sample come into being? Did I just pull random people off the street? How did I get these dots, these specific dots from the population? Where did I get these dots? Did I get these dots from the street right in front of the hospital? Because, yeah, 30% of people are sick. Hopefully the people coming out of the hospital are healthy. What test was used? How did I determine these people were healthy or sick? What test? Was it a thermometer? Did I just go up to them and say, hey, you healthy? No? Oh, that's unfortunate. I'll mark you down as a red dot. Who did this test? Did I do this test? Did a doctor do this test? Did a nurse do this test? Did some random hobo off the street do this test? Who did this test? Who figured out the people who were healthy and the people who were sick? Why? Why were we trying to figure out who was sick and who was healthy? Was this a study being paid for by the hospital? Did the hospital pay for this to be done? Did a politician pay to figure out who was healthy and who was sick? Because that could drastically change the results. When? When was this done? Was this done in the middle of COVID? Was this done last year? Was this done 2 years ago? 100 years ago? That could drastically change everything. Although this sample might be representative of the population, it might not be representative of the population now. It could be a very good representation of the population last January. That's great, but that is absolutely useless to us now. You have to be very, very careful whenever anyone talks about statistics. 74% of this group, or 75% of people believe, or in 80% of the cases this happens. You need to ask questions. Where was this sample done? Who did this sample? Why was this sample done? When was the sample done? What test was being used? Which questions did they choose? These samples get very complicated, particularly if we're talking about a big country like America. In America, there are a whole lot of people. And so to get a sample of Americans can be very, very difficult. Frequently, samples become biased. Biased samples are using a method that results in values that are different from the population. So my sample isn't actually indicative of what the population is doing. My sample has very little to do with the population. Unbiased are the good studies. These studies actually understand what the population is and have a good hold on being representative of that population. Biased is bad, unbiased is good. So let's take a look at what would create a biased sample, because most of the time, when you're talking about samples, they are biased in some way. So, for bias, what could cause bias? Well, let's start with age. Age can definitely cause a bias in people. If you want to figure out how a drug will affect a certain population, so I have this new drug on the market, it's a beautiful multivitamin, it makes everyone healthy, that's great. It's going to affect young people and older people very differently because they have different chemicals in their system, different hormones, they're taking different types of medication. You have to be very careful to study different age groups and make sure that your sample has all of the age groups. Gender. Gender is also a very important variable. Unless you are talking about ovarian cancer, you need to have different genders and different proportions of genders. Ovarian cancer, then you better only have people who have ovaries. Nobody without ovaries should be participating in your study. Otherwise, you need a balance because ovaries produce very different hormones and chemicals than testicles. So you have to be careful. Race. Certain drugs affect different races differently, and certain diseases, like diabetes, is seen in different proportions depending on race. Education. Some people with higher education levels tend to have different lifestyles than those with lower education levels. In fact, lifestyle as a whole makes a big difference, a very big difference. Different lifestyles can very drastically impact what chemicals and what hormones and what is in a person's system. So it'll definitely impact the drug. So you have to have a good smattering of a whole bunch of different people being in your study. If you just have the left side and you just have young guys, young white guys with medium education levels and no risky behaviors, that's not going to be indicative of your population of all of America. You also then need to look at those people and look at their records. What has happened to them in the past? Have they had cancer before? Have they had surgeries before? All of that could impact what happens with your drug. What is their lifestyle? Do they have a healthy lifestyle? Are they couch potatoes? What do they do? Money-wise, are they all on welfare? Are they all billionaires? Because yeah, billionaires act very differently than normal people. Religion also tends to act differently. In the Christian religion, many Christians in the springtime will not eat meat on Fridays. That is because of their religious beliefs. Now, they're able to eat fish, but they're not able to eat other meats. And Jewish people, a lot of Jewish people have to stay kosher, which means there's a whole bunch of rules where they can eat certain things, they can't eat other things, and they can't eat certain things mixed together with other things. Some of them are strict vegetarians because they don't want to memorize all the rules, or keeping track of all the rules is so difficult. Religion can play a very important role in a study. And then we have who funded the study. Fox News and MSNBC have a notoriety for funding studies that prove what they want to prove. And frequently they will fund certain studies to prove one particular point of view. If they want to prove that people are very devoutly religious, and so they take their sample on Sunday mornings near churches, they're going to find a whole lot of religious people, because that's when Christian churches have their services. So depending on who is funding a particular experiment or a particular study, it can drastically change the results. Those are biased results, and they are not indicative of the population, and they are not going to help you figure out how your drug would actually interact with the population as a whole. Okay, so we've got this population. We've got some red dots and we've got some blue dots. We've talked about all of the different things that could affect a study. We've made sure that this population is very indicative of what we want. How do we figure out who gets to be in the sample? So we've got a population. It's not all of America, it's just these dots. How do we figure out which of these dots get to be in the sample and which of these dots do not get to be in the sample? We know we've controlled for everything. So we try a volunteer sample. A volunteer sample is one of the worst decisions in life. A volunteer sample is a sample of people who just volunteer to be part of the sample. So we've got a sample and we say, who wants to report problems? Guess what? Everyone with problems gonna report problems. At which point, your sample says, holy cow, 100% of people have problems. That's not true in our population. That's not true at all. All internet polls run on volunteer sampling. There are many studies that try to do volunteer sampling. This is what Yelp reviews are all about, or Google reviews. Whenever you review something online, you are volunteering to do a review. That is not actually indicative of the population. So any numbers that those people get are absolutely useless. Any comments that those people get, not actually helpful, because that's not indicative of the entire population. It's only the people who have problems. Another absolutely terrible way to sample is the convenience sampling. A convenience sampling is just grabbing people who are easy to get. So we've got a sample, and I'm going to grab the people who are closest to my sample. Okay, so we've grabbed people who are closest to my sample bubble. And we've got 0% of people have problems. That's also wrong. If you notice, in this population, on the left side, fewer people have problems. On the right side of the population, there are a lot of people with problems. For some reason, on the right side of this population, Cloud, there's a big issue. We don't know what the issue is. But if we only take from the left side of the population, we're not going to get a good, obvious, clear idea of what is happening in this population. So, even if we control for everything else, how you take a sample can very much change what happens. It can very much impact what your statistics will show, and what they should show, and what they don't show. Depending on what biases you have and what sampling you take, these statistics end up being useless. So, when we have samples, how do we get useful samples? How do we get those good samples? The one that actually helps us? Well, that's an episode all for itself. So we're going to be doing that next episode. Stay tuned for how we find good samples in a very complicated population. The